So the second part of section 3.3 starts off with a slightly new concept, not terribly new. In the first part of the video, we did local maximums and local minimums. In this part of the video, we're going to do absolute maximums and absolute minimums. And each of the graphs that we're going to be given, we're going to be asked to find the absolute maximum and an absolute minimum. Each of the graphs, it's one continuous graph, and it doesn't extend. The endpoints are marked, so it doesn't extend to infinity in either direction. So the absolute maximum is going to be the highest point in the entire graph. The absolute minimum is going to be the lowest point in the entire graph. So as it shows here, this point right here, for this particular graph, I call it an absolute maximum, because it's higher than every single point on the graph. And this point right here, it's absolutely the lowest point on the graph, so it's an absolute minimum. We'll do the same thing about the value. Just like there's a absolute, a local minimum value and a local maximum value, here the absolute maximum value, I'm going to maybe write that absolute maximum value, it's got to be y equal to 2, and it occurs when x equal to 2 because that's the point 2, 2. This point, -1, -1, it would be like a local maximum because it's higher than any point close to it, but it's not considered an absolute maximum because there's points higher than it. And in here, we're only finding absolutely the highest point and absolutely the lowest point, not the local points. And then that point right there, the absolute minimum is -2, is the point 0, -2. So I would say the absolute maximum point, so the absolute maximum point is the point 2, 2, which is that point. The absolute maximum value is y equal to 2, which occurs when x equal to 2. This is considered the absolute minimum point, which is the point 0, -2. The absolute minimum value is going to be y equal to -2, which occurs when x equals to 0. So absolutes are basically the same as locals, other than the graph is going to be, it's not going to extend to any infinities. I'm not going to have to do increasing and decreasing for these, although I could, but I don't have to. I'm not asking for it. I just scan the graph, find the point that's higher than any of the rest of the points on the graph. That will be the absolute maximum point. And scan the graph, find a point that's lower than the rest of the points. That's my absolute minimum point. So not really particularly hard. So for problem 13, the absolute maximum point, the point 940 is higher than any of the points close to it. It's actually highest point of all the points on the graph. That's even more important. The point 34 is the very lowest point on the graph. That makes it an absolute minimum point. The point -120 is a local maximum point, but it's not considered an absolute maximum because there's a point that's higher. It's higher than anything close to it, but it's not the highest point. And then what's the value of the absolute maximum? The absolute maximum value is y equal to 40, which occurs when x equals to 9. That's as primitive as you should probably write for your answer. That would be completely fine. If I'm asking you to find the absolute maximum value or absolute minimum value, just writing the y and the x is sufficient. You don't need to give any fancy abbreviating. So for part D, the absolute minimum value is going to be y equals to 4, which occurs when x equals to 3. That's a completely adequate answer. My graph for 16 is a tough read. Let's do 15 together because that's too hard to read the points. The point 020 is absolutely higher than anything close to it. It's the absolute maximum point. The point 4, negative 12 is a local minimum point, but it's not absolutely the lowest, so it's not an absolute point, it's just a local. Anything close to it locally, it's the best, it's the lowest, but it's not absolute lowest. And the point negative 3, negative 60 is the absolute minimum point. And then for this guy here, the absolute maximum value is y equal to 20, which occurs when x equals to 0. The absolute minimum value is y equal to negative 60, which occurs when x equals negative 3. Now we're going to some calculator problems that I can't do in an algebra class without calculators. They are actually calculus questions. So I'm supposed to sketch a graph of the function over the given interval and then find the absolute maximum and absolute minimum. So to do problem 18, into my y1, I'm going to put the function x minus 3 squared plus 1. And for my window, I'm going to change the x min to positive 1. I'm going to change the x max to positive 6. I'm told only to look at this graph between x equal 1 and x equal to 6. I don't know what my y's need to be. They're usually set at negative 10 to 10. I'm going to leave them there. So I'm going to start off, I'm going to sketch a graph, and I'm going to get multiple y coordinates of my graph. I'm going to get the y coordinates of any maximum or minimum point best I can. So turn my calculator on. Y equals clear, then parentheses, x minus by the plus sign 3 x squared plus 1. That's the function I needed in my y1. Then I hit my window button. X min 1, type the number 1 and hit enter. X max 6, type the number 6 and hit enter. And everything else is fine. I don't really know what the scales do. Mine are always probably defaulted to 1. Now I'm going to hit graph. This is the graph that I'm going to need to use to understand my maximums and minimums. And very specifically, this graph goes from x equal to 1 to x equal to 6. So it goes like this. This is going to be the point 1 comma something. Goes to this. This is going to be the point 6 comma something. And you should know from some previous algebra class that this was going to graph to be a parabola. And this number with its sign changed is going to be the coordinate of the vertex, which that is. So I'm just going to change that sign and throw that down there. I know that that x equal to 3 is the bottom point of this graph. Now I need to get my y's. Let me lazily get my y's by using the table feature on my calculator. Let me first make sure my table is set up okay. Let me hit second in window for table set. If your table looks like this, it's fine. Just as long as this delta table says 1 and the other two says auto, doesn't matter where the table start is. Table start could be 8 for that matter. Makes no difference. But when you hit second in window for table set, delta table should be 1 and I should have auto and auto. Now when I hit my second button followed by my graph key, second in graph, I can pick out the values that I need by using my cursor. So the value of the y next to 6 is 10. The value of the y next to 3 is 1. And the value of the y next to 1 is 5. That's all I need now. I have everything. I've produced the graph myself. Well, technically myself. My calculator's produced the graph. Now I can answer my questions. The absolute maximum point is the point 610. The absolute minimum point is the point 31. The absolute, and that point's just a local maximum point. I don't need it right now. The value of the absolute minimum is y equal to 10, which occurs when x equal to 6. The value of the absolute minimum is y equal to 1, which occurs when x equals to 3. One more, and then we'll get into something new that's maybe old because we've done it before in another class probably. So let me sketch this graph. For problem 20, I'm going to sketch the graph in y1. I'm going to make y1 negative in the bottom row of the calculator, x minus the one by the plus sign, 4 squared plus 5. I'm going to make my x min in my window negative 1. I'm going to make my x max in my window positive 5. And I'm going to leave my y min and y max 10 and hope negative 10 and 10. And when I sketch my graph, the first point's going to have an x coordinate of negative 1, the far left point. The far right point's going to have an x coordinate of 5. And the vertex is going to be at positive 4 because I'm going to change the sign of that number in the parentheses. Let me just go ahead and get this graphed. So y equals, clear, negative in the bottom row of my calculator first, parentheses, x minus by the plus sign, 4 parentheses, x squared plus 5. Hit my window button, x min, negative in the bottom row of the calculator followed by 1, x max 5, leave everything else the same. Now let me borrow this graph. My graph went off the screen. I could see the x-axis here. My graph's not going low enough. It doesn't matter that I can't see the whole graph, but it might be better if I made my y min a little bit lower. Let me just sneak this y min to negative 20 so you could see a better picture. My graph was supposed to cross the x-axis. Now it does just fine. This is a better graph. So notice I snuck and I changed my window. Even if I didn't have a perfect graph, the table's going to help me answer the questions. But I like having a nicer graph. So the graph that I had here seems reasonable. It goes like this, goes up, and it starts tailing down. I've exaggerated the turn. It's more gradual, but that's okay. The points that I'm going to find are the point 4 comma something, 5 comma something, and negative 1 comma something. The reason the 4 is because this parentheses, I know how parabolas work, and changing that sign gives me the x coordinate of the vertex. Now second and graph for my table and hunt around. Next to 4 I should write 5. Next to 5 I should write 4. And next to negative 1 I should write negative 20. That's why I didn't see it. When I had my window at negative 10 for the min, this is why I wasn't seeing the graph. The graph got lower than I let my graph go. I still could have gotten the right answer without quite the perfect graph because my table would still give me the y's that I need. So there's my absolute max. My absolute maximum point is the 0.45. There's my absolute min. My absolute min is the point negative 1, negative 20. Let me answer the questions. The value of the absolute maximum is y equal to 5, which occurs when x equal to 4. The value of the absolute minimum is y equals to negative 20, which occurs when x equals negative 1. The next part of this, I lifted from intermediate algebra, I think. So you might have done this before. This is important specifically because it's a skill that comes up in calculus. In fact, this entire section is all calculus, doing it without calculus, doing it with algebra essentially, or doing what we can with algebra. I'm going to change my calculator back to normal. I'm just going to go zoom in standard just so the window's set up so that the next time I graph, it's ready for my graph. Even though I can't see a darn thing now, I don't hardly care. I'm just going to shut my, well, maybe I won't shut my calculator off. I'll leave it on. So 21, 22, 23, and 24, the last 4 problems, asks me to find the average rate of a change in a function, and it gives me two values. An average rate of change is a slope of a line that connects 2 points on a graph. Turns out that I don't need a graph to actually find an average rate of change, but I do need 2 points. So in each of the problems that we're about to do, 21, 22, 23, and 24, I need to create 2 points. And then find the slope of the line that connects the points. And the way the instructions are written, it's fine for somebody that teaches math, not so fine for students. When it says find the average rate of change, that means find the slope of the line. It gives me a function and it gives me numbers. These numbers are the x coordinates of the points. So the x coordinates are going to be 1 and 3. I can get the y's by hand. The first y, I can go f of 1, plug 1 in, is 1 minus 3 squared minus 2. Don't want to make a mistake this deep into a video, so let me do 1 minus 3 squared minus 2. My first y should be 2. My second y is going to be 3 minus 3 squared minus 2. Watch what I do on my calculator now. I want to just hit the second button and hit the enter key. That will bring up the line that I just typed. And because I'm just changing one number, I could use my left arrow, get my cursor flashing on that 1 and type my number 3. And it gives me a y of negative 2. So I have my 2 points. Now for part A, my average rate of change, I usually do this for change, the delta triangle. My average rate of change is going to be the y coordinate of the second point, which is negative 2, minus the y coordinate of the first point, which is 2, over the x coordinate of the second point, which is 3, minus the x coordinate of the first point, which is 1. This is going to be negative 2 over positive 4, and that reduces to negative 1/2. So in problem A, the average rate of change is just the number negative 1/2. I guess I could write m equals negative 1/2 if I care to. If I wanted to do the same for 22b, for 22b I need to create 2 points. The x coordinate of one of the points is 4, the x coordinate of the other point is 5. I'm using the same function. I need to do 4 minus 3 squared minus 2 to get the first y, 5 minus 3 squared minus 2 to get the second y. Let me do it lazy. Second and enter, back up, type the number 4 and hit enter. My first y is going to be negative 1. Second and enter, back up, change the y to 5. My second y is going to be 2. So my average rate of change is going to be 2 minus negative 1 over 5 minus 4. The double negative in the numerator becomes 2 plus 1, and I get 3. 5 minus 4 gives me 1. The average rate of change for part B is just going to be the number 3. There's 2 more problems on my paper here. I'm just going to do part A. hardly worthy of doing both of them. So for 24a, I want to find the average rate of change of the given function between x equal to negative 3 and x equal to negative 2, even though it doesn't say x is there implied. For my y's, I'm going to go parentheses negative 3 cubed minus 3 times parentheses negative 3 squared plus 5 for my first y. And my second y is going to be in a parentheses negative 2 cubed minus 3 times negative 2 squared plus 5. And no desire to do those by hand, so let me do this here. Parentheses, negative in the bottom row of my calculator, 3 parentheses, up arrow, cube. I have an old calculator, so it doesn't show the exponent. Actually, my good calculator, I have a new calculator, but I just can't get the screen to display for, oh, it almost shows okay now that I have a new light. Let me see what it would do here. So if I did this calculator, clear, parentheses, negative 3, parentheses, up arrow, cubed. Maybe you can see how it shows it as an exponent, and then right arrow to get out of the exponent, minus 3 times negative 2 squared plus 5. I get negative 34 for my y. Should get the same thing here, minus 3 times negative 3 squared plus 5. Oh, I don't know what I did wrong here. Negative 3 cubed minus 3 times negative 3 squared plus 5 feels good. Oh, on this one I changed my 3 to a 2. Let me second and enter here. You'll see that for whatever reason, that should be a 3 again. And I should have gotten negative 49 for my y. So my first y is negative 49. My second y, second and enter, change this x to a negative 2, change that x to a negative 2. My second y should be negative 15. The nice thing about this calculator is it has the ability to do fractions better than my older calculator. So my average rate of change is going to be negative 15 minus negative 49 over negative 2 minus negative 3. I don't use this calculator that often, but I know I could do calculators, fractions. On this calculator, if I hit my math button and go over to where it says fraction, and hit number 1, I get a fraction. And now I can do negative 15 minus parentheses negative 49, close my parentheses, over negative 2 minus parentheses negative 3, and get 34. On my other calculator, I would have to do this. It doesn't do fractions the same way. I do parentheses, negative 15 minus parentheses negative 49, close one parentheses for the double negative, close one parentheses for the numerator. The entire numerator needs to go in a parentheses on this calculator. And then divided by parentheses negative 2 minus parentheses negative 3, close one parentheses for the double negative, close the next parentheses to end the fraction. Still get that same number, 34. You don't have to use your calculators to get the y's. You can get the y's by hand. I don't have any issues with that. So the answer to 24a is the average rate of change is 34. I'm not going to do part B. I don't think it's particularly instructive. It's just going to be exactly the same computations. So give these a go. I always put average rates of changes on the test, because in the very first chapter in any brief calculus class, and maybe the second chapter in a regular calculus class, a chapter where you're not, well, the first chapter where you're learning calculus in any calculus class, you're going to do average rate of change. Average rate of change kind of connects algebra to calculus, so it's an important topic. I always test on it. All right, that should be it for section 3.3.